Welcome to Let's Start With That. I'm Gilles, and today we're going to make a burnishing tool. I've been curious about them for a little while, so I ordered one of those burnishing diamonds, and now we're going to make the tool. Let's go. All right, so here's the design. We've got the diamond. We've got the diamond holder, different views. We've got the pivoting holder. That's what's going to hold this. A couple different views. And of course, we've got the tool. I've changed the design multiple times just to make sure I don't overcomplicate anything. I'm going to start with this part quite simply because this here is going to thread into here. And if I have these threads made ahead of time, then when I make this one, I can simply test it out until the threads are just the way I want them. This material is 1 5/8 in diameter. We're going to want it at 1 1/4. So let's take it down. All right, so the second part is down to dimensions, and I'll get you to imagine, if you will, this is up, so we're like that currently, right? So the bottom is going to have this indentation here, which is going to fit in the tool and will allow things to pivot. A 1032 cap screw is going to tighten this up. So now we need to drill and tap a hole in here. So let's do that. Our hole needs to be at least 1/4 inch. So we're going to go a little deeper just to make sure that the tap can actually do its job right. Hey, here we are at 3/8. That's good enough. Alright, let's tap that 1032, and as you see I'm using a tap follower. That's a spring-loaded device. If you haven't made one yet, great thing to do for yourself in your shop. Makes things so nice. Getting some really good quality tap sure makes the job easier as well. And that's it. Okay, so I've made myself a couple of idiot marks. I am going to measure as I go, but I like to have these things because they're, you know, it's a nice visual indicator as to where you are. So we got to go 1/8 of an inch deep like this, because that's as much as we need to hold on onto the tool. And then we've got to carve out 435 thousandths in order to reach the proper diameter. All right, which is of course 3/8. Let's go. Excellent, super smooth. That's great. Might have mentioned this before, but if you're looking for a nice cutoff tool, you saw how this worked. I make them and they're available on my website at rogertoolscanada.com. Very nice. Now that 1/2" 13 is tapped, we've got to make a hole that's about 125 thousandths in depth at 5/16 of an inch in diameter to allow the diamond to spring into this pivot head. Now the spring is 240 thousandths, so we're gonna drill all the way through to let the spring into its cavity. Now I've had to turn this piece around so we could drill from this side. And the little trick I kind of learned along the way is you take one of these protractors, and I've got it at what, 89.8 degrees, that's close enough. So now I'm just going to realign my drill bit at 5/16 again and drill from this side. What I'm drilling for is that set screw that's going to be 1/4 inch long going in here. Its diameter is, it's a 3/8 by 16 TPI, threads per inch. I'm at 1/4 inch. I'm going to go a little deeper to allow my tap to work. 300, that's good enough. Next thing to be done is to drill a 5/16 hole all the way through. Try that diamond. Nice, perfect fit. So now we're all set. We've got to cut a nice angle in the front, and after that we're gonna cut this off, flip it around, and do the external threads, but we'll have to turn it down to 500 thousandths, half an inch, and do the threads afterwards. All right, so we've got our half-inch diameter. Now it's time to make some threads. All right. Okay, so we've got the pivoting head. So let's, we've got threads in here for our cap screw that's going to hold everything from the back, the spring and whatnot. But first, let's put in the retainer head. Okay, this was quite interesting and challenging to get that done just right. I actually had to grind down the tips of my taps to get far enough, but that's all right. And by the way, I'm not marring this. This is pre-hardened 4140. It's not getting marred at any time soon. Okay, so that fits nice and snug against the face here. And essentially, because there's no retainer screw yet for the diamond, I want to know how far it sticks out and how far it can go in. So let's put this grub screw in there. I call them set screws, but I know a lot of people call them grub screws. And it does go below the surface. I chose not to mill down that face. All right, it's of no importance really. Now we've got the spring. I did make a little bushing to go in there. It's 1/4 of an inch long, because the diamond wasn't sticking out, or yeah, it wasn't sticking out far enough to get the right amount of pressure. So as you can see here, I hope, let me zoom in a touch, if I can. All right. You see, here you see, I've drawn a line. This is where it sits, the diamond sits at its normal, right? And I wanted to see how far it'll go. So press down, and this is as far as it can go because before it reaches the bottom. So I made a mark there. Now we want to know where to draw the flat here. We have to mill a little flat in order for this set screw to go in and retain the diamond in its position, which would be about like that, right? And then this will allow for the diamond to spring in and out with the appropriate amount of force. So I took this, measured its width. It's gonna sit like right there. And so now I know I can mill from here to here, all right? And so we're gonna do that. And then afterwards, we'll have to drill and tap a hole for this set screw. So the first thing I'm gonna do is gently mill this here. I don't want whatever is holding that diamond, I don't want that to come off. All right, so that's where we're going next. Going about 10 thousandths at a time. I'm going to do that about 6 times. Hopefully you can see this here. There. That's how it looks. So I'm now going to file that down. And then after that, we're going to come back here, take the retainer head, and drill and tap. Okay, we've got that face milled there on the diamond. Now it's time to measure where we want that hole to go. I've put a mark here in yellow, and you can't see it here. And that's to indicate to me where the top is located. Let's just do this in black here for you. Anyway, it's there. And so I want to know where to punch that hole. So the easiest way to do that is we already measured that this set screw is going to sit here. So let's put it there. Okay. See if that'll hold for me. And since that's where it is, just have to line up. Let me see here. First of all, okay, so when the diamond is in, it sits here, right, with the spring. And we want it to go not as far as it'll bottom out, of course. We want some spring action happening. So if we do this, and we put it as far back as we need it to be, as it can go. And we put it like that. That's about where it sits when I compress the spring, and there's still give about, you know, another 1/8 of an inch to go. So that's where I want to put that screw. Okay, so I've made a mark. And now I just need to make a little cross lined up with where I want it to go vertical. Make a punch mark. Now really got to be careful because once we go to the, I'm actually going to use the mill to drill because it's quite precise. There we go. That should allow my drill bit to get in there. Okay. Time to cut some flats. I'm going to make them so that I can use a 1/2 inch wrench. So the diameter currently is 611. It'll take 55 thousandths from each side. We are firmly in the last phase of this project. So I've got an AXA quick change tool post, which means I'm using 1/2 inch stock here. This is 01 tool steel. So we're gonna cut this here feature. This is 1/2 inch tall, of course. So I've made a mark here at 1/8 of depth of cut. I've got a circle of diameter that's going to be fit this. I've got a 2-inch face mill. That's what I'm going to use to do the feature. Once we've got that done, then we're going to drill a 3/8 375 thousandths hole. That's going to be also 1/8 of an inch deep. And then through that is going to be a hole to accommodate our 1032 cap screw, right? So let's get to it. In case you're wondering, these are the drill bits that I'm using are 8% cobalt. They're really tough, cut very cleanly. Now let's see if our pivot fits in here. Nice fit. Excellent. Good. Okay, so all of the milling and machining is done on this thing. I've taken the time to do some lapping just to get rid of any nicks and imperfections that I could see. Let's look at these parts here, because we haven't done that yet. This is that head, the holding head. The pivot head is a lot more complicated, as you've seen all of the different machining that we've done here. So you look at that here, there's different diameters, etc. And of course this to retain it on the tool. And the tool itself is interesting as well. Okay, so let's put this together. And then I'll have to find a part to turn down and see what that diamond can do. All right, so let's put that thing together. Pivot head, all right. We'll put that little screw in there. That's the retainer screw, right? All the way in. Can always, that's to adjust the spring tension if I really need to. Okay, so at this point we've got to put in this. Take the wrench. There you go. It's in its spot. Now, springtime, we'll have that little bushing. Put in our diamond. And now at this point, we need to insert this 832 grub screw. Ooh. Make sure it's where it needs to be here. Okay. All right. And now, put the pivot head into the tool. And I like it the way it fits. You can turn it whatever degree you want. And that's the only thing I didn't do to this tool is put some sort of degree graduation, but I don't think it's super necessary at this point. Okay, and it holds very nicely. There's the tool itself. Voila. Now I did make this fair bit longer. This is 4.5 inches long versus 4. And the reason I did that is because I wanted to be able to use the AXA tool holder to hold this thing on all 4 screws. All right, so let's go and machine something and let's try this puppy out. Okay, so I've turned a piece of tool steel. So now I'm going to install the burnishing tool, and there you go. I've already centered it using my centering tool. If you haven't had a chance to see them on my website, this is what they look like. They look very, very simple, but actually they're extremely accurate within 0.02 degrees. So once you get this level, you just put it in your chuck, you level it, and you just put your tools against it, and that's it. They're very handy. Okay, so this is what this looks like before we use the burnisher. Now I'm going to be using some oil on that. So let's just put it right against it. And I'm not bottoming it out, but pretty close. So let's turn this at, say, yeah, around 270 RPM, and let's see what happens. Put some oil. These things like oil. That's pretty impressive. Wow. Amazing. I'm not sure if you can see that correctly here. Yeah, that's quite the change. That's pretty impressive. I wonder, let's run it backwards and see what times 2 does. Put some oil right now. All right, here we go. Well, that's impressive. It really does flatten out the ridges. Hopefully you can see this correctly. That's I mean, let's move you and let's have a better look. So look at that. That's pretty wicked. I mean, the difference, and everybody always does the nail test, it is remarkable. I can't find a better word for it. It's impressive. There you go, I replaced remarkable. Okay, so now I know that this works, and it's going to work for a lot of the jobs that I do around here. It's going to be a real game changer. Now, some of you might be interested to know about what kind of diametric change occurs when you actually use one of these burnishers. And I'm not going to cover that in depth, except to mention that all of the reviews that I've watched online seem to show that the ridges get pushed down and leveled between 1 and 5/10 of 1/1000. So it's not a big amount, but if you're chasing tenths while you're machining on your lathe, then you need to be aware of that. And I would suspect, and I would suggest that you perform some testing on the material that you have before actually doing it on the real piece. Well, anyhow, I hope this was useful to someone and that you enjoyed the process of this video. So with that said, please like and subscribe, and shoot me a comment. I always love to hear from you. Take care. Bye-bye.